All right, folks. So the main thing here is we're talking about constructions. And some of you, literally, you're going to get into, architecture drafting from like enjoying doing this because it is kind of fun to make constructions in the classical way. So in the classical way, we do not use rulers, no rulers, because as you were mentioning before, if I said to copy this segment here, and you're like, well, I measured it, and it was 1 13/15 of an inch. Then you'd have to go and repeat that and find 13/15 of an inch. Really, really hard to do that accurately. So instead, the classical way is no rulers. You just use a compass and protractor, straight edge. That's all you use, because the actual measurement, the tangible measurement, 1.8 centimeters, whatever, that's an abstraction. It's actually the distance between A and B is exactly that distance. That distance. I could put it here, I could put it there. That's the actual distance. So the classical way to do these, and they've been doing this kind of constructions using just a straight edge and compass since ancient Greece. Pythagoras learned it this way and taught it this way because the units are going to change over time. So we need a way to produce things without knowing the units. Okay. So let's look at what we got to do here. These are the fundamentals: making a line segment, copying it, and also copying an angle. So first, everybody go ahead and use your compass, and we're going to make sure that the points are approximately the same location. If one leg is longer than the other, that's going to cause trouble. So don't, if it's like this, make sure that they're about the same distance. So it's flat. Good. And then make sure it's closed all the way so it doesn't slip. That's the key. Now you're going to hold the compass with 2 fingers up here. You're going to hold it up here and anchoring, really put most of the weight on the leg that has the little spike on it. And then all you have to do is lean it in the direction that you're going and rotate it. And we practiced that a little bit before with just a piece of paper. So you'll want to practice this. A lot of the difficulty of this is getting used to use the instrument because, it's new to us. So let's start doing this construction. No rulers, just these 2 items. Use the compass to measure the distance. All right, I'm going to do that. Use the compass to measure the distance. Find it as well and accurate as you can. If you're using a paper clip, it's probably going to be frustrating, so just do your best. So I did A. I measured the distance. I know that is AB. That's AB right there. Okay. So now measure that distance from another point that I just put anywhere, C, and it doesn't matter. It doesn't matter where you make your arc, but instead of just doing this and making a point, this is how we do it. Put the pointy spike on C, and then what we're going to do is actually just make an arc. We're going to make a small arc right here. And this is how we do distances. This is called a construction mark. So I put the point, the spike on C, and all I did was I made an arc just to find the distance. And this distance, right, this distance is the same as that distance. Anywhere along the arc is still AB. It's still that distance, okay? So I have this as my anchor point. I just made a little arc. Now what I'm going to do is place a point on that arc anywhere. See, this is the same distance from C. This is the same distance because these are all radii, same radius. So go ahead and make a point, label it D. And then all we have to do is go back in and connect them. Use your straight edge. Boom. Perfect. Okay? So a lot of this is keeping in mind that if I do a rotation, look, I could have put it way over here. I could have put the spike there and using the same distance. I could have made a mark over here. And if I were to connect this point to C, it would be the same distance as well. So a lot of students are having issues because they're like, I don't know where to put the point. But it doesn't matter if it's here. It doesn't matter if it's here because remember, this distance, we made the arc. We made the arc with the distance we wanted. So any point on the arc will be the same distance from A to B. Easy? This one's pretty easy, right? That's the first one. It goes really far. We're only doing 2 today, but this goes, there's like about a dozen like really different ways you do things. And we'll just work through them slow. Okay, so we're done. We've made our copy. We'll talk about another option further when we get to the practice problem. Now, next what we have to do is copy an angle, okay? So copying an angle is a little bit different. So the thing is, I want you to go ahead. It doesn't matter if your angle matches mine. We definitely are not going to go measure the angle. We're not doing this as a measurement. We're doing this as a construction. Okay, so that's the big difference. We don't use measurements with construction. All right, so go with me with this. I want you to put your compass so that it is inside, inside the angle. Notice if I do it like this, look how wide I have it there. If I decide to make my arc like this, it's not touching my rays of my angle, so that's not helpful. It's only about finding an arc that you can put in here that is within the angle that we're talking about, right? So you see I made this arc right here. I made this arc right here, and I'm going to keep this distance. I'm going to keep that distance. Oh, how did that happen? Slip. Okay. I'm keeping this distance because that's going to be helpful for my next step. You see how that's exactly this arc. This arc is created by this distance, okay? So we use the compass to measure the radius from J. We made this arc. We know that this is the radius from J. And then what we're going to do is we're going to go down to our point R, and first we got to make one of our rays. So go ahead and just put it anywhere. Notice how I thought, okay, maybe I'll do it straight, but then I decided, nope, I'm going to do it down just to show you that it doesn't matter. So where you put that ray doesn't matter, because all we're doing now is finding the angle by opening up the other ray so that it matches it, and there's a way that we do that. Okay. All right. So everyone has ray R set up like this. Now watch. Remember, we kept the same distance here for our radius from J. So now put the spike on R, and anywhere you want, make an opening that's about the same. I keep doing that. I keep slipping because I am. So make your arc length so that it's approximately, the same opening, even a little more. I could have gone way over here, and I could have made it more than I needed. Right? So all we're doing is creating the same arc length as the radius on the top. This radius J to the arc length is the same as R to the arc length. Thus, I know that this distance, right, is the same as that distance, is the same as that distance, because it's all the same radius. Okay? All right. Now the thing is, now we have these set up. All we have to do is figure out how far do I open up my other ray to match it. And the way we're going to do that is we're going to use the compass to measure the distance between the rays. I want you to get your compass and now measure exactly this distance. Measure the distance here. And what we're setting up is the opening of the rays that creates the angle is this far apart at that arc length that we created. And that arc length is the same distance as the one we're creating here, the one we're constructing. So watch what I'm going to do. I know that this distance is how far it opens. So put your spike right here. You see? Put it right there at the bottom. And then what we're going to do is, oh, it moved. So anytime it moves, you got to double check and put it back. Okay, that's how far we want it. So I'm going to put my spike right at the lower intersection of the ray, and I'm just going to make a little arc. I'm going to make a little arc here where it crosses my original arc that I had made. See, because this distance now, we've set it up, this distance is the same as this distance here. You see how this matches now? That one matches this one. Okay. So as long as we created our arc the same distance from our points, then we know that this distance is going to be matching this distance over here. Okay, let's make a point. Make a point at that intersection, use your straight edge, and finish up your ring. And now we have two congruent angles. Now it's definitely like a tempting thing. It's a tempting thing to erase it. This is like you didn't know, but watch. Don't erase your construction marks. That's actually key, because I can't go in there and tell if someone has just like measured it out. But if I see that, I want to see like this, we had a tick mark here that told me that you measured that distance. we have these arc links. So you can actually just don't erase, just keep them. And I know it sometimes, you know, I might erase this part over here if I just went too far, but I don't want to erase any of the main tick marks. Okay. All right, at home, let me know on a scale from 1 to 5, how do you feel about this process? What are you guys thinking here? Is doable? Okay. But you see how it's like a different mindset. You're using this to kind of make a bunch of different arcs. You'll see that's where it gets more complicated. We'll keep going further. All right, good. We got 4 and 5. Good. Okay. So now we're gonna try this, and we'll get it. Get it for you. So let's go ahead and do a few more. Okay, I want everybody to go ahead and let's make it a little longer. So use your straight edge and just make any length that you want. And let's call this AB. All right, so this is the first one. And it does not have to match how the length of mine. Yours just has to be, you know, straight. You have to use your protractor to make it. And just go ahead and get that down real quick. Okay. So what we're going to do is we're going to, for example, 1, we're going to construct CD. I'm sorry. Sorry. That's not it. Construct a copy of AB. That's what I meant. And we're going to call that CD. So go ahead and put C somewhere down there. So we're construct a copy of AB. This is the same thing we did. So if you want to just go for it, the same process. It gets a little trickier in the next ones, but we'll see about that. Okay. So what do I have to do? Let's see. I need to first just make a line array going away from C. Okay. Just make a line going away from C. Because if I'm making a new segment CD, I could put D anywhere along this and just say it's just segment CD. So then I would just be looking at this. Right now it's array, but I'm going to kind of isolate where D is so that it'll match. Okay. So let's see what we got to do. Let's go ahead and open up the compass. So it's between A and B. Get as accurate as you can. That looks pretty good to me. And then what I'm going to do, put the spike on C, make an arc, just crossing the line. You don't need to make too big of an arc. We know it's just going to be that distance, you see? Because when I make that arc, I know that it's showing that exact distance. That distance, if I spike it at C and make the arc, it is exactly the same distance, you see? Okay. And then let's go ahead and put a point right there. We'll call it D. And we got it. No problem. All right. All right. And then how about this? For 2, we're going to construct a copy of, we'll call it angle G. And I want everybody to make a different angle G. So just start by making the bottom ray. We'll call this G right here. But I want you to put the other side of that, the other ray. You know, if you want your angle to be that big, you can do it like that. If you want it to be really wide open, you can do it like that. It won't matter. If you want it really narrow, you can do it narrow. Just put the other line there, and then I'll put mine in, and we'll see that it doesn't matter how you make your angle. I'm going to go and do mine a little more regular. I'm going to do it right here. Okay. So that's my angle G. Do you guys have something similar or different? Similar? Okay, so probably most people picked the acute angle. But if you did it, you know, more like this, an obtuse angle, it's going to work exactly the same. Okay, so let's do our process for this. let's go ahead and get our compass so that we can put the spike on G. And this is where I'm choosing, right? I could choose this if I wanted to use my, microscopic, doc cam to make crazy small arc lengths. I could decide to make it this big, but that's not helpful for, that's not helpful for anything unless you're using a really, really tiny compass. So instead, why don't you go ahead and make it so that it's just, I don't want to make it too far out so that it's beyond my rays. I want to just make it so it's inside the rays, and I'm going to keep that and go ahead and do a spike at G and rotate it. Okay. So I look and I make sure I did it right. Yep, that radius is the same as that radius, is the same as that radius, same as that radius. All those radius are the same because I'm just rotating it, right? That's what a compass does. Okay, next, let's go ahead and make a point down here. We'll call it H. All of these kind of start with, making a ray. So let's make a ray. And watch, I'm not even going to make it the same. I'm going to make my ray go this way. It won't matter. So if you want to challenge yourself a little bit, do it that way, and we're going to make it open. We're going to make it open this way. It won't matter. It could be upside down because I'm doing pure distances here. Now look, here was my radius. So what do I need to do? I need to make my radius, let's see, is that right? I need to make my radius off of H now. And I'm going to do it in the area that I'm going to make my angle. So I'm going to go ahead and make it, wide enough that it looks like it's as big as the other angle. You see, I'm just making it any direction. So my angle is going to be up here. My angle is going to be up here, but you could have put it anywhere you want. Okay. Okay. And it takes some practice, but really focus on keeping the weight on the spike. Keep the weight on the spike anchored there, and then really the movement is just barely using that pencil. You don't really want to push hard on that pencil. It's practice. You just get it as you practice. Okay. Next, what are we going to do? How far did it open? So think about that, right? This opened up this far and has a distance from where it started to the place where it ends. That's what we're duplicating. How far did it open? And let's go ahead and figure that out. Let's go do it. It's about that. You see? Since it's about that distance, pretty dang close, I'm going to go here, and now I'm going to find that same distance from one of my arc intersection points. I'm just going to make a little mark. You see how I don't have to push very hard? I just push it, hard enough to get a little mark on there, and that's all you need to do. Okay. And intersection right there. Don't erase your tick marks, all your construction marks. And let's go ahead and make our final point through there. So I know, like, those that become, like Kim mentioned, she wants to be like an architect. You're going to use AutoCAD. You're going to use online tools for this. But like for drafting, there's still some applications where this is like a real classical thing that just helps you understand constructing. It's kind of like the front load, the preload to be able to do it digitally. Okay, so and there's a part of it that's going to be outdated. I mean, but you're like the last generation that's going to probably learn this because AI will be building all of our houses soon, and that's like 20 years away. So your kids won't know anything about this. All right, in the chat, let me know on a scale from 1 to 5. How do you feel about, we did each of these now twice, and now we got to go to a harder problem. Feel good? 4? 4 is this? Okay. And that's where it's just like, we just got to keep practicing. All right. All right, Tavia, perfect. Thanks for answering. Let's do the last one, number 3. Last one. Okay, I want you to just get your straight edge, and I want you to like put this one more upright. So make just like a line segment here. We'll call it AB. Okay. So what we need to do is construct 2 AB. 2 AB. We're given AB, we got to construct 2 AB. And maybe we'll call that CD. It doesn't matter. Okay. So now think about this. If I'm going to construct 2AB, first off, we're not measuring it, so it might be even too long for the straight edge tab. So maybe you got to just, wherever, go ahead and make another line. Make it longer than you'll need. Okay. Make it longer than you need. Because 2AB, we can say this is 2AB. We don't have to use all of the line. Right now it's a line. We're gonna make a line segment that's 2AB. Let's go ahead and put 1 point on the new line. Let's call it C. And how about in the chat? Somebody let me know what is a strategy for this. Because we kind of know how to create, we know how to reproduce just AB, right? We know how to reproduce AB. So how could we do 2AB? Let's think. I mean, there's a bunch of different ways we could think about it. How about this one? Now, I think you guys are just into learning the actual way. And you're like, just show it. Okay, so look, this distance, go ahead and measure this distance, AB. Measure the distance pretty well. Get as accurate as you can. And then watch what I'm going to do. Spike at C. Get one of them. Okay. And that's AB right there, right? This distance is AB. All we have to do, and this is how they like navigate ships. You ever seen like in the like Pirates of the Caribbean, they like go like this, and they go duh, and they go duh, and they make their way across the ocean? That's all they were doing. Because they have on the bottom, you ever see the maps where it has like this is equal to 5 miles, 10 miles? On the bottom of a map, it'll have like a scale where you can see, okay, this is 10 miles. So then they're like, okay, we're 4 miles from that from that island. Okay. So what I just figured out, I got to put it back here. I know that this distance from C to my tick construction mark is the same as AB. So now all I need to do is, this is where my first mark went. I'm going to put my spike on that mark and make another. You see? So let's see if I kept it. Yeah, that and that. Okay. So I know AB was this distance. When I spike on C, I get to here. And then I just have to spike on that point and move it a little further. And here is, we'll call it D. And we'll say 2B is equal to CB. Right? Okay. I'm going to add one more to this. So keep this all together. And what we're going to do now, this is more like the homework. So I want to give you one problem before we wrap up the lesson here. So I want you to do this. I want you to do, okay, we're going to make a new line. So just make a new line segment, shorter one. Just make a short line segment here. And let's call that EF. Okay? EF. What I want you to construct, I want you to construct AB minus EF. Yeah. Think about it. What is it asking them? Because this is a measurement, AB, right? Minus EF, right? So it could be like, I can't think of anything right now. You're cutting different pieces of rope. You're setting up a swing set in your backyard for your cousin, and you're figuring out how much you got to cut off. It's basically the length of AB minus EF. How are we going to do that? How are we going to do that? It sounds like first we got to produce what AB is, right? Because we're going to take off some from the AB. We're going to have AB here. We're going to take off some, and what we're taking off is EF. So let's go ahead and do that. Let's make a new point. Let's do our same process real quick. Get your straight edge. Well, these are just arrows right now. We'll call it G. And then let's go ahead and figure out where AB would be. So since we're doing AB minus EF first, we got to find out where AB would be. Let's see. Here's AB. So if I do this, same like step every time. If I'm just reproducing a line segment, dang it, I'm having trouble with it. Okay. So this distance here, if I call this GH, I know that GH is the same as AB because I just measured and reproduced GH and AB are the same. So now what do we have to do? We need to subtract out. So this is AB. And we need to subtract out EF. So here's how much rope we bought. We need to subtract out EF. So we have to put EF in between G and H. We have to figure out where it is. And my thought is we just move this distance, EF, we move from one of the points, either G or H, in, and then we could say that little segment is equal to GF or EF. So watch, go to EF, find that distance, right? Find that distance. And then from either, you can go from H or from G, just go ahead and make that little tick mark, construction mark, how we know how to do. We'll call that I, and then maybe I even want to label that this HI is equal to EF. Okay. You see what we've done is basically just used AB that we had before. EF, we constructed AB, we constructed, EF in between from one of the endpoints. And now what this actually equals, AB minus EF is equal to this little part here. Okay. AB minus EF is equal to GI. Yeah, essentially you have AB, you're cutting out EF. What's left over is AB minus EF, and we'll call that GI. Okay. All right, how about again another kind of end of the lesson on a scale from 1 to 5. How are you guys feeling at home? How are you feeling here? Okay, still like just more practice, and honestly, I think this, right? Yeah. Getting that to be clean. All right, good. We got 4s and 5s, a couple 3s, and Ava, I think it's a 3 because lack of having the protractor. Yep. And once you get it, you'll have no problem. Okay, thanks for watching at home.